Thank you. Welcome, everybody. First of all, I would like to introduce ourselves. Here with me is Chris Xystras, a senior DevOps engineer from our team, and I am Christos Pateritsas, one of the heads of development in XM. Before we proceed, I would like to ask you quickly a few questions. It will be fast. First of all, how many of you here are developers? Please. Okay, a lot of you. How many of you are DevOps engineers? A little bit less. Okay, I see. And how many of you do both? Okay, thank you. So the context is mixed, so we will try to address challenges from both sides. Hope you find it interesting. Okay. So I will very briefly, don't worry about it, present you who are we as XM in order to give you some context about the company and what we do. Again, second part, very brief, I will give the context about the project that we're going to talk about. And the last part is I hope the most interesting one, the challenges that we faced to our journey to the cloud. Okay. So who is XM? Probably you saw that in the morning, so I will go very quickly through it. We are a retail forex broker operating almost everywhere in the world with millions of clients, with offices around the world. And the most, let's say, important probably that you mind from all this is we actually, as an IT department, we develop a big range of applications for all of business flows inside the company. You will see more about that in the next slides. And of course, okay, we are a great place to work, just to let you know. Okay, sorry. Okay. Very fast also, our IT department spans across various countries, mostly our headquarters in Cyprus, but also our big office here in Athens. Now, but in other locations also. Now we are more than 300 people on a rapid growth. A couple of years ago, we were probably 150 or something like that, so we doubled our size. We are a polyglottal company, having a diverse stack of technologies. But as I said before, as an IT department, to deliver software that covers a variety of functions from trading, obviously, that's our job, okay, but also internal operations like accounting, CRM, KYC. We develop our own tools for all these functions. Obviously, risk management, reporting, and all this stuff. Keep that. We will revisit that a bit later on. Landing in the USA. Okay, so 3 years ago, the management decided that it's time to expand our operations in the USA market. The USA market is the crown jewel of the financial markets, is a very highly regulated market, and also with a very educated client base. Okay, so it was a big challenge for the business, and what is a challenge for the business is obviously challenging for us. So 2 years ago, in 2019, we started our journey to launch a new brand, because that was the business decision, to to expand in the USA region, not with the XM.com brand, but with a new brand, Trading.com. So you can visit that at trading.com/USA. And since, for regulatory reasons, we were obliged to deploy a new infrastructure, totally new infrastructure for this brand located in USA, we took the decision, why not this time do it in a better manner? Okay, so that was our, let's say, key point where we decided that this time we are going to go cloud native as much as we can. But back then we started with limited experience in Kubernetes and in AWS, no containers in production, no infrastructure as code. During these 2 years, from 2019, it took us almost 2 years. More than 50 people worked on the project. Almost 500,000 of commits in multiple repositories, a lot of studying, obviously, to get this going, and many challenges that we will focus later on. And in early 2022, we launched Tradingcom USA. Key points, all applications now are containerized. All of our infrastructure is on AWS, and all our applications are deployed in Kubernetes in the corresponding AWS service. And all our infrastructure is provisioned through infrastructure as a code. So we have a we are talking about a full-fledged web and mobile applications. And just a note here, corresponding to what I said before, we're not talking just about trading. We deployed all application stack for this brand. So we just copied the company, but we also revamped the company in a cloud-native manner. So just to give you the scope. Okay. A high-level overview of our architecture. We're talking now about almost 60 different applications in Kubernetes, a lot of AWS services in order for this to work. The decision also was to use AWS services, managed services, as much as we can, because this is the cloud-native way. To get the context of our size, 700 pods application instances running on the production Kubernetes cluster, CI/CD pipelines developed for every change that we do, obviously for applications, but also for infrastructure, for configuration. We automated all these changes. And through infrastructure as a code, we managed to replicate this environment 4 different times, relatively easy, to help the development process. Just to name a few, for example, our access layer is composed by Amazon API Gateway for HTTP and WebSocket connections, authentication through Amazon Cognito and Lambda functions. Our compute, our execution layer is mainly our Kubernetes cluster with the small server farm of dedicated bare metal servers for the core trading server for regulation reasons. We use also Kafka and Kinesis for the event stream, storage layer with a lot of AWS services, DynamoDB, DocumentDB, Redshift, S3 buckets. And we try to monitor all this architecture through services like New Relic, Grafana, ELK, and Prometheus. Okay. So when we started that, obviously, we were very motivated. We had high expectations. It's going to be a walk in the cloud, we thought. Okay, we never saw that movie. The reality hit us hard. So a lot of challenges there. And I give the floor now to Chris. He will start presenting you a few from his side, and I will continue with a few more later on.
Hello, everybody. I hope you are a little bit familiar with Odysseus and the myth. Odysseus goes through a journey from Troya back to his homeland Ithaca, and he stumbles a lot of challenges in a lot of ways. Briefly, our challenges were a lot, and we'll just mention a few for your assistance as well. Lot-to-zitters, Kirki, Cyclops, Sirens, you name it, this guy has been through everything. So for us, the biggest challenge was cloud adoption. How do you go from on-prem to cloud in a company that's already established, there's already a customer base? We have investigated a few frameworks. We have tried to find different methodologies, different procedures. We ended up with Cloud Adoption Framework from AWS. We tailored it to our needs, of course. And through Cloud Adoption Framework, we needed first to establish a Cloud Center of Excellence. Cloud Center of Excellence is merely, let's call it dictations on how the organization should be structured, should respond department to department, procedures, automations, even touches HR. And what we have been lacking mostly was committees and processes. Let's go through our journey now. So, cost. If you are dealing with cloud, you know the Kool-Aid, the whatever everyone would like to hear. Cloud is cheap, cloud is easy, cloud is extensible. Well, really not. So things can get out of hand really easy, really quick. There have been a few startups that didn't see the build. You probably have seen also the meme that a guy left an EC2 instance running, and he ended up in poverty. The company needed the cost optimization committee, and that's what we have established. We have been through weekly reviews of not only the cost bill, because the bill comes at the end of the month, and later on your resignation. Cost anomaly detection is a very nice feature that you can use. You get notifications based on your monitor threshold for any trend going outside. And we have used that a lot in the last couple of years, and we managed to catch some expenses before they go wild. Saving plans and reserved instances, another thing we needed to revamp on. We already had saving plan. It was just one saving plan, but going to the cloud, we exploded. As Christos said, we have doubled in manpower, and our resources, well, I don't even know the number, the multiplication. We have started, as I said, with one plan. Next year, we did 2 plans to decrease our delta, our difference. Now we are at the point where we have a 3-year plan as a base, covering 75%, and then we are tackling deltas with additional plans whenever we see a leveraged need. Reserved instances, the same. You pre-book instances at a specific instance class, and you have the option to do that for 1-year or 3-year contracts, and it gives you a lot of discount. Actually, through saving plans in regards to EC2, we managed in the first 6 months of 2022 to cut back 47% of our EC2 expenditure and around 7% of our total. So that's just pre-booking, and you start to see the savings. Programs and incentives from cloud providers, helpful programs that might help you, especially if you're on AWS, Migration Acceleration Program, MAP, or Enterprise Discount Plan, EDP. Do look them up. They are programs that will help you move towards cloud and cut back on cost. Instance Scheduler, it was, we had a need actually to stop idle instances that we were using them only on specific timeframes. For example, whenever we wanted to test something in staging, or we had an instance doing work only during weekdays, whereas in the weekends it was not doing anything. It's a solution provided by Amazon. Of course, we and you should take it and revamp it, tailor it to your needs. We have done that. We have added on top of it a lot of stuff, and we gave it the code name Hypnos. Serverless and right sizing couldn't go undetected. Whenever you have the need for it, I would suggest you go for it. There are downsides as well for this, but especially for lower environments like dev and test, there is no need for you to have an instance there being provisioned. It also saves you from management costs, either those costs being currency, dollars, euros, whatever, or man hours. Last on this, we needed to expose costs based on service, on region, on project tag, on cost tag, and we have done that through the cost awareness reports. These reports were not just to point the finger to someone, it was just to raise awareness where we are going on the wrong side, where we still have room for growth, And we are not doing any actions from the cost optimization committee to stop anyone using or anyone's development or innovation. We are just there to help save ourselves. Next challenge we had, simulating to Kirki, was the solutions uniformity. You all know probably whoever is designing the solution has a different idea than the person next to him. He sees things differently, he gets into his own universe, and just goes down his road, and even that might be wrong. So we needed a uniformity in those. We have done our research again, and we have decided to follow the well-architected framework of AWS with its pillars and TOGAF. TOGAF is the open group architecture framework, and it's again dictations, procedures, how solutions should be made and how they will be most helpful. The committee took those two frameworks and designed its own flow. Flow consists of different steps, but each step is broken down further. For example, researching what's out there, what we can use, the feasibility study, if it's something that is worth putting our people do it, or for a few bucks we can get a tool to do that, or if we need to do that, that would help someone from our teams to develop or grow. Then we have, of course, the POC, then we have the solution, then documentation that nobody likes. And finally, we come to the acceptance and the review, and then back a life cycle for revamps. Of course, through this flow, we are checking with best practices as always. Security is a very big aspect. Shift security to the left, if you are aware with that term, it means to tackle security early in your phase, in your solution design phase, whereas you won't be needing to do that later on and have back and forth all the time. So you reach until staging and network security tells you this is wrong, this is unacceptable, design it all over again. We have seen through this flow that our members started being more innovative, creativity was ramping up, they were growing as engineers, so better mentors, better onboarders, quicker in troubleshooting, more experienced in solutions. We have seen them by themselves taking on event-driven, where in the past they were not taking it, and it's only gaining from that. We have managed to streamline our solution deployment from a month and a half to 2 months down to 3 weeks. Next up for us, resiliency verification. For Odysseus, this was Cyclops Polyphemus. You probably have heard the famous motto of everything fails all the time. And this is actually a license for the doing members to break stuff, actually break stuff. It's not fun when you're on the other side, of course. Chaos Engineering Committee was the call to that. We have investigated the chaos engineering in general through these couple of years. And it's actually a process that you induce real faults into your architecture, into your processes, and you are waiting to see if the automation works, if the people works, if the process works, and what actions are taken. It's very, very helpful. It helped us a lot. Of course, there are best practices out there, but don't get tangled to them. Tailor it to your needs. Basic steps dictate that you should have 4 steps. Establish the steady state, hypothesis, actions, and results reviews. For us, we added a couple of more, and we have used Amazon's fault injection simulator, FIS service. To properly do that, of course, you need meaningful data points, measurables that actually mean something to whoever will see them. The CEO might not understand that you have a a sub-second latency, but they need to be translated in such a form that they will also understand it. Of course, the flow of the whole experiment itself, whatever you are getting as a result, as an output from one wave, you feed it into the next, and you have that in your steady state and hypothesis, and you expect not to see that repeating itself again. Just a side note here, we added also backup and restoration exercise to this process. In the past, it was more standalone, but we decided to add it there because it's actually more related. We have simulated, let's say, an SQL injection or a fault at the web server, and we engaged our teams to restore from our backups to verify actually if the backups had any data in them. It did work greatly, I might say, and that took us about a year to streamline it completely, and we had a recovery time objective of 5 minutes in one system and maximum 1 hour in another system. Being in our line of business, latency is of essence as much as you can imagine. We need lower latency even than banks. So for us, it's very, very crucial. And before going into a little bit of our experiments, let me just say that the corrections we have done where we decreased Windows nodes deployment time from 12 minutes down to 5. That was huge for us. Improved alarms, improved logging. We noticed that some of the logs were missing. We noticed that some of the alarms didn't trigger. That was the best way for us to see those things. And of course, our processes. We worked mostly on our incident response management process, readiness exercises, etc. So a little bit more into our chaos experiments. As you can see here, in this experiment, we were terminating an EKS node, and the automation was detecting it, picking it up, spawning a new node, scheduling pods to it, and life goes on like any other Sunday. Stress tests, very important. You probably had, if you work with containers, you had rogue containers that were taking up resources from everyone else. We have stress test the nodes themselves in CPU and memory. We got our alarms. We saw that the automation was working. We corrected a few things in our process. And next iteration, next wave, we saw the results of that exercise. Now, for this one, we have tried to simulate AZ failure. I don't know if you guys worked with AWS. If you remember, a couple of months ago, there was an AZ failure in London. Because we have done that exercise, we were not affected in our flow, in our environments. Next up, we wanted to see something within the cluster. So we have done our scripting, our magic, and we managed to use fault injection simulator to terminate pods, either all except one pod and see the rescheduling, or all pods. Request swarming is probably one of our best experiments. So you expect to have load and you scale for that load in your application, but what would that load mean to you? For example, you go from 1,000 requests to 10,000 requests. What if it's 1 million requests? Would it be able to handle it? So for us, that was the way. And again, our team worked were really, really nice on that. We got very nice outputs. FIS addition, as you can see, it does use CloudWatch alarms for stop conditions and writes output to logs. So you still have logs for your experiments. Next challenge, our processes. It was sirens for Odysseus, and we needed mostly to work on these two, our investigation process and our incident response process. So for investigation process, there are different frameworks, there are different templates that you can find. Some guys call it root cause analysis, some guys call it correction of error, whatever that is called. It's a process that starts whenever you are mitigating the alarm, and then when you are sure that the alarm does not repeat itself, the issue, the incident does not repeat itself. It's very depth, it's very prolonged, it gets people crazy, but it's very, very crucial. Incident response, the guys back at XM did tremendous job. We saw that going cloud, as we said, exploded our resources, so we had far more systems to monitor. We needed a very streamlined process for that. Runbooks, playbooks, metrics, alarms, investigation, all these were revamped, rechecked. We saw them failing, false negatives, false positives. Notifications, here we have even implemented Amazon's solution provided for health awareness. Again, we have revamped it. We have tailored it to our needs. We have that sending to our paging tool, to our pager. From the pager, the proper team gets notified, there's escalation. Code name for the system for us is Hermes. And our investigation calls, war rooms, you might know them. Again, they were revamped. We have, of course, less than before, which is a win right there. Next challenge, containers and orchestrator. Now, this is the new trend. This is what helps businesses nowadays. For Odysseus, it was bugs of Aeolus. We had close to zero experience, and now we are close to expertise. The team does amazing things, automations kicking in, the whole sort. We went from a few ECS tasks to what we have now, 6,500 pods in more than 10,000 containers. A little bit more specific, our deployments are a very few less than 1,000, over 180 daemon sets, and 16 EKS clusters. Now, how we did it? Of course, we got our hands dirty, really, really deep research, trials and error, a lot, banging our heads against the wall, fixing, breaking, fixing again, breaking again, whole cycle. We managed to find even a few bugs, like Windows with Kubernetes controller. If you need further information on that, come see us at our booth. Regarding EKS upgrades, we managed to have zero downtime EKS upgrades. The same with Istio, and these two provided help for our team to even revamp and achieve blue-green deployment in applications. Security can go undetected. NetSec guys helped us a lot here. They did a tremendous job again. We managed to not only isolate and segregate environments, but we also managed, and we are doing inspection on images, on pods, containers, versioning, etc. Logging and observability, again, a major thing for containers. Just a brief there, a comment, we are using EFK and New Relic with Prometheus and Grafana, and the magic happens behind those. Last, for me, deployment. Although I'm not a developer, I feel developers' pain about this. I know probably most of the guys, you don't want to deal with this. For Odysseus, it was Scylla and Charybdis. Infrastructure as code was the answer, is the answer to anyone. And consider that the new black. It's a new trend that ramps up really, really quick. So where we are now, we have fully adopted infrastructure as code, and not just infrastructure, but also configuration, application, data, everything as code. Terraform versus CloudFormation, the big question for us. We chose Terraform, multi-cloud, you know the rest. Our account structure took a really extensive configuration, a lot of accounts, but yet it's simple and easy to use. Rebuildable, of course. enabled version control and flow control, permissions, approvals, comments, cost even on plans, etc. Just for you to understand, we managed to deploy a similar infrastructure for a new brand that was taking us before a couple of months, let's say, to less than 2 days with infrastructure as code. Those consist of 4 clusters, MSK clusters, databases, EC2s, etc. But more on this and from the developer side from Christos.
Thank you, Chris. So I will add a couple of comments on this from the developer side, as Chris said. So why developers should care about infrastructure as code. So when we started this journey 2 years back, we took the decision that parts of the infrastructure will be handled by the dev teams. So that would enable the development teams to deliver solutions end-to-end and do it in a faster way and have ownership of the infrastructure that they use for the application. Obviously, this applies to resources that the application uses and they are not shared across other applications. For example, a dev team does not provision the Kubernetes cluster, but if an application wants to use a DynamoDB or any other similar kind of resource, the dev team will write the code, the Terraform code to provision that resource. So we still support this. This helped us a lot, removed a lot of work from the DevOps team, shift the ownership for some parts to the dev teams and give them more capacity and capability to do stuff. But there are some concerns here. Okay, Terraform is not a rocket science, but as your infrastructure grows larger, there is a learning curve, there is some complexity. So is one more thing that you have to go with the dev teams, they have to learn about it in order to be efficient. And the second thing, obviously, since we are talking about infrastructure, you cannot let full control to the developers. So we have established, we are in some cases use also the DevOps team or the security team to review the code, the infrastructure code that the dev teams are delivering. So you have to establish processes about reviews, about who merges the code, how you propagate these changes to the infrastructure across environments. Okay, since now you are talking about writing code that spans across teams, or another team approves your code, then you have to put the right process in place in order not to have bottlenecks in this process. Now, moving on to a different challenge from the developer side of things. Okay, so the cloud-native development. Well, when you start thinking about developing applications that are going to run in a Kubernetes cluster using AWS managed services, you have to think a little bit different than the way you were doing stuff before, because first of all, the operation infrastructure Kubernetes does not behave the same way like an application server in a big VM or in a big bare metal server. So you have to take these specificities under consideration. Maybe not enough memory, not enough CPU power. You're sharing these resources with other applications in the same cluster. So you have to design your applications smaller and be more thoughtful of the rest of the world. And second consideration is the services that you use from AWS. Okay, so each one of them have their specificities. I will just give you an example. For example, DynamoDB. I don't know how many of you have used DynamoDB. It's like a serverless database. It's actually, you can consider it a key value store, but you can also build indexes and you can have queries and scans on the data. And you have to understand how these scans or queries operate, how is the most performant way for you to use them. It's not a traditional relational database, but it's also not a Redis cache. Okay, so you have to deep dive on this in order to design your application properly and use that effectively. Okay, and one more thing to consider here, serverless is fine, is wonderful, but as Chris mentioned, there is a hidden catch here, pay as you go. So the cost now you have to take that in consideration during your design, okay? Because you are going to pay as you go. You have to understand the billing model of each of these services and take it into consideration. As I said, how the Kubernetes environment works, and last but not least, security. Okay, cloud security. We're not talking here about SQL injections and CSRF attacks and all the things that usually developers try to prevent in their applications. We're talking about how you secure your infrastructure and your application and your services not being publicly exposed or be exploited. And since part of this provision of the infrastructure is done by the developers through the Terraform, through the infrastructure as a code, they need to understand a little bit the security aspects of the cloud and the networking in order to set up this effectively. Obviously, this should be done with the help of the security team or the DevOps team, that they have the expertise on that. So as a key takeaway from this is, okay, try not to make assumptions about how the cloud and the services and the serverless services work. In AWS managed services are not going to fit every purpose that you have. Okay, they are not silver bullet. I will give you just a very brief example about a functional requirement. For example, when we are designing our login flow, the business said, okay, maybe we should have a feature not to allow the 5 last passwords to be entered or reused when you reset or change your password. Okay, very nice. Sounds it's also a good security feature. But we are using AWS Cognito as authentication service, which is also great because we don't have the anxiety of safeguarding the passwords of the users. AWS engineers do that for us. But Cognito doesn't offer this functionality, the password history. Okay, so what have you do? You have to think about it and do some compromise. That's a small example. You can find a lot of examples on different services like that. So what can you do about that? Obviously, read the documentation, but not just the front page. Okay, this service sounds good. Let's use it. Okay, deep dive, understand the details, the error handling, because it's not only the sunny cases. Sunny cases might be nice. It offers you what you want, but how the error is treated on the AWS side. You have to understand that if that fits your error flows. Okay. So the answer is probably start always with POCs. Okay. Do proof of concepts. Be sure that the architecture that you design will fit the purpose, or do the necessary compromises early in the beginning. Be aligned with the business that this is what we will offer for this and this reason, and that's acceptable. Otherwise, you will have nasty surprises very later down the road of your delivery. Okay, and again, last but not least, performance. As also Chris mentioned, performance is very important for us. We are in the trading business. We are talking about milliseconds latency. We have to offer to our clients. And so, again, take that into consideration as early as you can on the design phase of your application. Test it, not just think about it, test it. Because the problem here is that if you find a performance bottleneck further down the road, and this performance bottleneck maybe it's from the use that you do from one of the AWS managed services, then you are probably in a bigger trouble because you cannot go and improve or change that service. So maybe you have to remove it and replace it with something else. And this will affect your application design. And then you will go back to the board and start all over again. Okay. And you understand the problems with that. So test the performance also. And since now the architecture becomes a bit more distributed, a lot of different services here and there, some of them black boxes, it's not so easy all the time to stress test your systems, or when you are stress testing them, to gather the necessary metrics, the inside logs, in order to evaluate where your problem is and how to fix it. So you might need to create tools or create some frameworks from the early beginning in order to do that also. Last, forgot, sorry. You pay for your performance tests because pay as you go, we said, so keep that also in mind. Now, very popular for the developers, microservices. Obviously, being cloud native, it's almost synonymous of adopting the microservices paradigm for your application design. We ended up with more than 50 services, as we said before. Well, we didn't have we did this great shift to the cloud, but we didn't have the time to rewrite everything from scratch in terms of application code, obviously. We would need 10 more years to do that. So we had to use some of our applications also in the new brand. Obviously, we containerize them and we are deploying them with a cloud-friendly manner. But this means that we didn't have the chance to do a proper domain-driven design in terms of microservices, try to reduce the dependencies, isolate the business flows or the domain in specific microservices. So we have a significant number of dependencies across some services in some of the business flows that the applications serve. And when this becomes too large, then there are several problems. I will just mention the one that we faced mostly was the deployments and how you orchestrate the delivery of features that span across services. So if you have to do that also across 4 environments, and you are also in a phase where you have, let's say, so many people developing in order to deliver a product, you are not, let's say, on a maintenance mode, or you have the product there and you are adding features, you are creating stuff. Okay, then if you don't try to orchestrate your releases somehow, do proper versioning, identify very effectively which version of one application depends on which other version of the other application, have visibility what has been deployed across environments in order for you to know, or a dev team to know, that the dependencies are there, so they can go ahead and release their own changes. You will end up with a chaos where everybody is asking, did you finish that? Is it deployed? Yes. Which environment? Oh, it's to test. Okay. We then have to push it to staging and all this back and forth. So establish release processes if you go down that path. We did that. Especially for the upper environments, the production and the staging, we're establishing a very strict release process, not only to help us get away from this mess, but also because it's a regulatory requirement to have proper change management in place in order to prove to the regulatory authority how our platform evolves through time. So that were the basic challenges that we face. To wrap up a few things, and just as main takeaways from this, we mentioned it a lot of times during the challenges that we described. Beware of the cost. We had the luxury of funding this project from another brand, which is very healthy. But if you are on a smaller organization or you have a tight budget, things can go very bad very quick, as Chris also explained. There is a learning curve. There is a learning curve in almost everything that you touch: infrastructure, deployments, pipeline. So prepare yourselves for seminars, reading, training early from the beginning before you get your hands dirty, and while you also do it, continue reading whenever and whatever you can. And last one, don't make assumptions, try everything, break it, as Chris said, fix it, measure it, and start all over again. Unless you have the luxury of having in your teams people that have done this a lot of time and you know the exact details and can tell you the way to go, I think this is the only way to proceed. Expect that. If you remember also the presentation from the morning, it's similar to innovation. Have it that in your roadmap. We will try things. Some of them will not work. We will have the commitment to go back and fix them and try again. Okay, it's not a bad thing. We are learning as we go. That's all. Probably we don't have room for questions. But feel free to meet us in our booth in order to ask whatever you want about these challenges. And don't forget, if you haven't done already, go to deadbullxm.com, play our magnificent game, win awesome prizes. Thank you a lot.